Hi, my name is Jimmy Larson, and I'm going to be presenting a paper that looked at remote sensing in apple orchards or apple trees and to quantify water stress. So the authors looked at 3 different types of remote sensing. They used hyperspectral imaging, NDVI or normalized difference vegetation index. That's a measurement of the reflection of near infrared light minus red light divided by the sum of those two, and that gives the value between 0 and 1 for vegetation. So healthy vegetation will reflect more of that near infrared light, absorb more red light, giving a value that's closer to 1. Then they used a digital camera to measure leaf area index. They subjected apple trees grown in pots in a greenhouse to 5 different watering treatments, and those were expressed as a percentage of field capacity. So the well-watered one was 100% field capacity, and then it went down to 90, 75%, 60%, and the most water stress treatment was 45%. So in this graph here on the left, we can see that their water treatments did indeed stress the plants, but there's differences between those watering treatments. And so the 2 most stressed ones, 60 and 45%, did have higher soil matrix potentials than the other 3 who had soil matrix potentials that were quite similar. So the 100%, 90%, and 75%, the others found no difference in water stress. With the 60 and 45%, those trees were indeed more stressed. And this bears out in the hyperspectral analysis signature. See kind of between 560 and 700, those plants that are more water stressed are reflecting more of those wavelengths than the unstressed trees. And then at the end of the spectrum, from 850 onward, those trees that are healthy are reflecting more of those wavelengths, and then the stress trees are absorbing those. So that speaks pretty well for NDVI, which in a correlation analysis, the authors found that for regular NDVI, that correlated pretty well with the data. So that's R value of 0.82. And then red edge NDVI, which the authors said was a narrow band NDVI, where they focused just on a small portion of the electromagnetic spectrum that had a higher correlation coefficient of 0.94. So that captured a little more of the sensitivity in the data and was able to distinguish between groups a little better. So yeah, here that narrow band red edge NDVI focused on this part of the vegetation reflection curve where there's a real steep gain. So differences between groups were able to be teased out a little more easily. So the authors concluded that hyperspectral imaging leaf area index that they calculated from the digital camera pictures and then NDVI all were able to capture differences between treatments. And then between the 2 NDVIs, red edge was a little better than the broadband NDVI at capturing differences. So this kind of showed that hyperspectral imaging will work, but then you can focus in on specific wavelengths, so more of the multispectral to see differences. And then as it pertains to my research, I wonder if these same wavelengths will be important for carbohydrate stress that the authors found were important for explaining water stress. Thanks.